Today we're looking at various ways of solving quadratic equations where we have x to the power of 2, we have a quadratic, and so far we've been practicing solving this by factorising it, and this is the one of the easiest ways of doing it, or perhaps using the calculator is an easy way too, but we know that if we factorise this, we make two brackets which equals 0. When we talk about solving, if I did a graph showing whatever quadratic this is, it's where the quadratic cuts the x-axis. So here I've got two factors that make -10, so I'll have a -5 and a +2. We've practiced our factorising before. So I know at x equals 5, if that's 5, and at x equals -2 would solve it, and x equals 5 would solve this. So at those points, my quadratic cuts the x-axis. Whoops, missed there. Those are the points where y equals 0 at those points, and these are we can also call them our roots. Okay, we're also looking for, we may be asked to find the roots of an equation, and those roots would then be x equals 5 and x equals -2. So let's have a look. Say we factorise say we factorise an equation, and we end up with 4x and a bracket 3 minus x equals 0. What are our roots, or how can we solve that? We need to, in order to solve it, we need to make this bracket 0. So here our x must equal, to make the bracket 0, the x would equal 3. 3 minus 3 is 0. Or we can make this outside the bracket 0, and in order to make 4 times what makes 0, x equals 0. Those are our two solutions. In this case, our graph would look like at x equals 0 and x equals 3, the parabola is going to cut the x-axis. So these are our roots, or our solutions to the equation. Okay, let's do a few more examples. Let's say we had x and 4x plus 1 equals 0. We're looking to solve that, so we want to find what makes this equation 0. So I can see this x here. If I made that x equals 0, everything in the bracket would be multiplied by 0, which would make it 0. So that's one of the roots, or one of the solutions. Here I make this bracket has to be 0 also. That would solve it. So I have 4x plus 1 equal to 0. I can just solve this like a normal problem. My 1 comes to the other side, it becomes a -1 if I minus 1 on both sides. So 4x equals a -1. Get rid of my 4, divide by 4 on both sides. So I end up with x equals -1/4 would be the other root, or the other solution. Now in some problems, if you give you the solution and you have to find the equation, so you're working backwards. So they may say if x equals 3 and x equals -2, find the quadratic, or find the equation of the graph, find the quadratic or find the equation of the graph. So we know if these are our roots, we have x in two brackets here equals 0, and we know that one of our values of x is 3 and the other value of x is minus 2. And if I want to make these brackets 0, 3, I'd have to do a minus 3 there, would make that 0. A negative 2 to make this 0, I'll add in positive 2, won't I? 3 minus 3 is 0 in that bracket, and x plus 2, negative 2 plus 2 would make that 0. And if they ask for the quadratic equation, we can do our FOIL on this. First, outer, inner, last. So we'd have x squared plus 2x minus 3x minus 6, which would be x squared minus x minus 6 equals 0. That would be our quadratic equation with the roots of x equals 3 and x equals negative 2. Let's try another last one. So let's say they say if x equals 4 and x equals 1/2, what's the equation or possible equation? So we know that our in our brackets we have our x here and an x here, and it equals 0. So I know to make this 0, my x here is a 4 and the other one is a 1/2. So I can fill in my bracket. If it's 4, take away 4 is going to make that 0. And a 1/2, I could put a minus a 1/2 here. Okay. Another way of writing this would be an x minus 4. When I have x minus a 1/2, if I multiply everything in that bracket by 2, 2x minus 1 would also be true equals 0. Because if my x here is a 1/2, a 1/2 times 2 is 1 minus 1 is 0. It's a tidier way of writing it instead of having a 1/2. Okay, so that's how we solve by factorising.